That's not quite so obvious is that it actually has 5 stereo cameras, and it's using those cameras to actively map out the world. What that means is that it'll see if something's 30 centimeters or below, it will step on it. If something's above 30 centimeters, it will see it as an obstacle, so it will avoid it or navigate around it. So this is what we would call athletic intelligence, and makes it so the operator only has to give the robot high-level commands. Basically tell the robot to go here or go there, and it figures out the rest. That also makes the robot terrain agnostic, meaning it can go on stairs, gravel, graded walkways, and areas that are typically difficult for traditional robots with wheels or tracks. In addition to its mobility, it has the ability to hold up to 30 pounds of different payloads. And we've seen payloads like thermal cameras that you see here, acoustic sensors to look for compressed air leaks, gas sensors, LiDAR to build out digital twins or 3D scanning maps. And the beauty of that is that helps us provide value in 3 different areas. The first is going into environments that are just not safe for humans. So think about a nuclear power plant or a decommissioning site. Today, someone has to walk in or bring a sensor in there and absorb some dose rate. What about just putting that sensor on the back of the robot and someone drives it in and keep the human out of harm's way? And we have customers doing that right now. The other is going to logistically challenging environments. So think about an offshore oil rig. Instead of getting in a helicopter to fly out there, what if you just teleoperate into the robot from a command center and do the inspection you need to do? And the third area is bringing a level of autonomy into environments that really weren't designed for autonomy. So think about an industrial facility that was built 50 years ago, before automation was a thing. With Spot's mobility and IoT sensors mounted on the back of the robot, you can have it go on a particular path and take hundreds of scans on a daily basis, and then use that analytics and that data from those scans to make decisions on predictive maintenance for your plant. One thing I'll point out on this robot is it's equipped with a fully integrated arm. So that arm does a few things for us. One, it gets us to more places because you can open doors with the arm. It can grab objects, pick up objects, drag objects. If you find an issue, like we've been talking about with the sensors, it can remediate that issue by turning a valve, pulling a switch, or doing something like that. The last thing that I'll point out is if you look at the screen, there's a new concept that we're working on that has a high-tech lighting system. And this is designed to give visual cues to people in the area around the robot, so you understand what its behaviors and movements are going to be. The reason for this is to improve human-robot teaming capabilities. So that's a little bit about Spot. Hopefully it was helpful. And we're excited that you all have been a part of our journey today. So thank you very much. I'll pass it over to Caslin.
Wow, Spot truly does perform a variety of functions, and I look forward to its various activities in the future. Let's go ahead and give another round of applause for Boston Dynamics and Spot. So moving on, we will have a robotics performance with a theme focusing on mobility. For this next session,